Yes, good evening, Akash. So, what are you doing? Atoms and molecules, right? So, in the atoms and molecules, we are discussing about the atoms and their symbols. Okay. So, last topic is atoms and the symbols. Now, can you say what is the symbol of silver? Symbol of silver. Very good. Ag. Symbol of iron. Fe. Very good. Next, symbol of bromine. Br. Very good. Next, symbol of gold. Au. Symbol of mercury. Symbol of mercury. Hg. What is this? Hg. Okay. So, very good. So, you learnt about the atoms and molecules, but still some more elements you have to learn with their symbols. Okay. So, these are the some of the mostly asked elements what I am writing on the screen. Right. Chalo, so let's go to the so here you see these are the mostly used symbols in the 9th class as well as 10th class. So, you have to learn these element symbols along with the first 20 elements. So, first 30 elements actually you should know, first 30 elements from hydrogen to zinc. Okay, 30th element is zinc, from hydrogen to zinc you have to learn. Okay. So, here you see the mostly used elements or this one. Aluminium is Al, argon Ar, barium Ba, boron, bromine, calcium, carbon, chlorine, cobalt, copper, fluorine, gold, hydrogen, iodine, iron can also ferrum, and lead, magnesium. This is lead. What is its Latin name? Pb. Plumbum. Very good. Next, magnesium Mg, neon Na, nitrogen N, oxygen O, potassium K, silicon Si, silver Ag. What is the silver Latin name? Argentum. Sodium Latin name? Latin name of sodium? Natrium. Sulfur, uranium, zinc. Okay. So, these are the some of the mostly commonly used elements. So, along with this one, these are not in okay, order, but you have to learn according to atomic wise 1 to 30 elements also you have to learn along with these elements. Okay. So, this we learnt in the last class. Now, come to the next one. So, here we discuss about the atomic mass. I think already atomic mass we discussed in the atomic structure, but here why it is taken atomic mass, that we are going to discuss here. Okay. So, how do you measure the atomic mass? What are the units to measure the atomic mass? Yes, Akash. What are the units to measure the atomic mass? Yes. Atomic mass. What are the units? How do you measure the atomic mass? Okay. Atomic mass is measured in AMU, that is called atomic mass unit, okay, or unified mass. What it is? Unified mass. So, you can say AMU, atomic mass unit, or you can say just U, So that is unified mass. Okay. So you know that to measure anything we require one standard one. Yes or no? For example, what is your weight? Okay. So then you can say that my weight is like 40 kgs or 45 kgs. So here what you are doing is kg you are taking as a unit. Yes or no? Right. Now for example, if you want to measure the length of this room, or if I ask you what is the distance from to your school from your house, then you can say sir approximately 200 meters or 300 meters you can say. So you can say that that is 300 meters or 200 meters, means what? Your meter is one standard unit. So we are comparing. Okay. So this is a meter, this is a standard one, and with this, okay, if I count 200 times of this one is my school. So that is 200 meters. Yes. Now similarly, if you go to the shop to get a milk, then when you ask them about the milk, he'll say that how much milk you require. So you say like half liter, 1 liter, 2 liters, 5 liters, 10 liters. So here to measure the liquid, we are using one unit which is called as a liter. Okay. So if you taking 5 liters milk means what? 1 liter into 5 times. Okay. Standard one is 1 liter. Okay. That you are taking 5 times, 5 into that standard one. Okay. So to measure anything we require something is standard, right? Now atoms are very small, already we discussed in the last classes. Okay. Atoms are very small, they are invisible to us. Okay. We cannot to see them. Then how can we measure the atomic mass? Okay. What should be taken as a standard for to measure the atomic mass? Okay. So here now now they have taken in 1961. Okay. In 1961 sorry, universally it was accepted that the 12th part, very important. So this is very important. The 12th, okay, the 12th part of carbon mass of the carbon is taken as a standard, okay, which is equal to 1 AMU. Is this clear to you? So they have taken carbon, and they have again here in the carbon also we have the isotopes. Already in the atomic structure we discussed. Isotopes means what? Atoms having same atomic number but a different mass numbers are called as isotopes. Carbon isotopes also available. Carbon, natural carbon is available with the mass number 12, and radiocarbon is also available with the mass number 14. So here carbon 12 is taken as a standard one. Carbon 12 is taken as a standard one. So they have taken the carbon 12, means the carbon with the mass number 12, okay, with atomic mass 12, and that mass is exactly divided into 12 parts. The mass of the carbon 12 is divided into exactly 12 parts. Now each part mass, okay, the mass of each part of that 12 parts is taken as a standard one, and that is given as AMU, atomic mass unit, okay, or unified mass. Now based on this one, the atomic mass of the other elements are calculated. Based on this one means what? This 1/12 of carbon mass is taken as a standard one or is taken as a reference. By taking this as a reference, the atomic masses are calculated. Okay, the relative masses were given to the all atoms. Is this clear to you? Right. So here you see now, atomic mass of an element may be defined as the average relative mass of an atom of the element as compared with the mass of atom of a C12 is taken as a 12 AMU. So here they have taken carbon, okay, carbon as a standard one, okay, and carbon, which carbon? C612, okay. So this one, here 6 is its atomic number and 12 is its mass number. 12 is its what? Mass number. So this carbon is taken and they measure the mass of that C12 and the mass of this carbon, okay, mass of this carbon C612 is divided by 12, okay, it's divided by the 12. So then what is a mass? Okay, we are getting that mass is taken as a 1 AMU, 1 atomic mass unit. Is this clear to you? The meaning is what? Here 1 AMU, again you multiplied with 12, then you will get okay, 12 AMU, which is equal to the mass of okay, carbon, the mass of carbon. Okay, is this understood to you? Mass of one carbon atom. So 1 AMU, if you multiply again with the 12, so you will get a mass of one carbon atom. Means what? One carbon atom mass is divided into 12 equal parts. Each part mass is taken as a reference as a 1 AMU. So, and this 1 AMU again you multiply with 12, you will be getting carbon mass only, yes or no? For example, you think this pen is there. For example, this pen is 12 kgs, you think. What I am doing? I am breaking into 12 equal parts. Okay. Now each part become how much? 1 AMU. Okay. Again, if I join, what I will get? The total mass of this pen I will get, yes or no? Right, similar to that one. So this is very important one. Now atomic mass of the element may be definition. See, if they ask you the how can you define the atomic mass, means how can you define AMU? Okay. The average relative mass of an atom of an element as compared with the mass of atom of 12, okay, taken as 12 AMU, means what? 1 carbon mass is taken as 12 AMU. This is most important thing you have to remember. Okay. Now, so here in 1961, for a universally accepted atomic mass unit, carbon 12 isotope was chosen as a standard reference for measuring the atomic masses. So, here you see, I think you might have studied in the lower classes or somewhere else. In different countries, they are having the different references. Okay, you know that the CGS system, MKS system, FPS system. Did you study this anywhere? So CGS system, like distance. Okay, C is measured in centimeters. Okay, and like mass is measured in grams, and time is measured in seconds. Okay, length, mass, time. Now, so in some countries they used to measure with the CGS system. Then some countries FPS, okay, length, mass, time is measured in FPS. What is F in that? Foot. And P is what? P is pound. Okay, and time is same, that is seconds, FPS. Similarly, MKS, meter, kilogram, second. So like this, different countries were using the different system. So now it will be difficult, For example, we are in India. We are using, for example, you think CGS system or MKS system, and we are going to some England. You think in England they mostly they will use that FPS system. Okay, here I can take like I can measure in kgs, I can measure in meters. For example, I want to stitch this blazer, I need some, for example, 2 meters of cloth, and if I go there, so there they will be measuring in terms of foot. So I will be confused, I don't know, like actually I want 2 meters cloth, but in terms of foot, how many foots becomes 1 meter, it will be confusion, yes or no. So that's what in the 1961 the scientists all gathered together, and they decided that universally there should be only one system of one system, okay, should be there to measure the anything, okay, any physical quantity. So then they decided that, okay, there are some physical quantities which are called as the fundamental physical quantities, and those fundamental physical quantities, actually 7 are there. So they decided that we required actually 7 fundamental physical quantities, and we required one standard unit for that one. So then they introduced one new system called as the SI units. SI means what? A system of international or international system of units they decided. So like this, here also universally accepted. So in 1961, for a universally accepted atomic mass unit, carbon 12, okay, carbon 12, okay, isotope was chosen as a standard one, So C12 is chosen, that is taken as a standard one, okay, standard reference for measuring the atomic masses. And one atomic mass unit is a mass unit equal to exactly 1/12 of the mass of one atom of carbon. So the meaning is what? 1/12. Okay. So 1/12, 1 by 12 into mass of carbon. Mass of carbon. So 6 and 12. Now this is taken as 1 AMU. Is this clear to you? So that is taken as 1 AMU. So that is about the atomic. The relative atomic mass of all elements have been found with respect to the atomic mass of carbon 12. So after that, now they started comparing. Okay, now they started comparing the other elements mass with this mass with 1 AMU. Okay, and then they have given the masses to that elements. Okay, for example, if you see hydrogen, so hydrogen mass is equal to this much, is equal to approximately equal to this much. So that's what they are given as 1 AMU or 1 unified mass. Okay, now if you see carbon, however 12 we know. Okay, then nitrogen, then when they measured, when they compared the mass of nitrogen, so the mass of nitrogen is 14 times of this 1 AMU, 14 times of this 1 AMU. So that's what they are given the mass of nitrogen as 14. Okay, similarly oxygen mass is 16 times of AMU, so 16. Sodium mass is 23 times of 1 AMU, so that's what it is given as 23. Similarly magnesium 24 times of 1 AMU, so 24, 27, 32, 35.5, 40. Okay, so like this they are given the atomic masses to all the elements. Clear?
Sir, one magnesium atom is equal to that means 2 carbon atoms.
What?
Magnesium atomic mass is 24 now, sir. And 12 AMU means 1 carbon atom. Is that meant for 2 carbon atoms is 1 magnesium?
Right, you can say like that. Okay, carbon atomic mass is 12 and magnesium atomic mass is 24. So you can say that mass, magnesium mass, okay, mass of magnesium is equal to 2 times of mass of carbon. Yes, you can say that, no issue. Right? Okay, so like that. Now, so this mass, how we are expressing? We are expressing in terms of AMU. In terms of AMU. AMU is what? Atomic mass unit.